Myself Sohit, and today in this video we are going to solve the problem of the day of GFG. So we have the problem: construct a full binary tree. First of all, let's understood what is a full binary tree. So it's simple. It's kind of a binary tree which having either each node having either zero child or either two childs. So this kind of tree is called full binary tree. Okay, moving to the problem, we have given two arrays, pre and pre-mirror, of size n, containing unique elements, where pre represents the pre-order traversals of a full binary tree and pre-mirror represents the pre-order traversals of its mirror tree. Construct the original full binary tree using these traversals. Okay, so this is the complete questions. So in the questions we have given pre-order traversal of a tree, and when we mirror the tree and then again take the pre-order of the tree we have given, and we have to return the root of the tree. Okay, so how to make a full binary tree like this? First of all, let's understand what does that mean, pre-order. Okay, so we have three terms, first called root, left and right. In the pre-order, what exactly we will do? We will take print first root, then go to left, then go to right. For example, here, if we starting from the 1, then this is our root. Okay, then we will first explore the root. So we will first take root. So we will print 1 and then go to the left. So again, this will be root. So this will also print. Again, we will go to the left. So it will also be the root. So it will print 4. Now root and left has been done. Then we will go to the right. It doesn't have any right. So then we will backtrack and go to a node 2 and then check it has right. So we just print 5. Then again we will move and then we will move on 3 because this is also root. Then go to left. Then again left side we will check. It doesn't have any. So we will move on 7. So in this way we will traverse to the pre-order. So if you see the cursor, it goes like this: 1, 2, 4, then 5, then 3, 6, and 7. This is called pre-order traversal. Okay, so this is we have given in the pre-order, and stuff we have given pre-mirror. What does that mean? If we mirror this, if we mirror this tree, and whatever the tree we will get pre-order, so we will get this array. So these two array we have given. Okay, if we analyze the pre-mirror carefully, then we will get it's nothing but the first traverse the root, then go to the right, and then go to the left. What does that mean? Follow my cursor. We will first traverse root 1, 3, 7. So these are root. Then we will go to the right. It doesn't have any right. Then move on the 3. It has the right. So 1, 3, 7, 6. Follow here as well. 1, 3, 7, 6. Then this part has been done. Then right part of 1 has been done. Then we will move on the left of the 1. So again, it will go to the right first. So it will go 1, 3, 7, 6, then 2, 5, and 4. So it's following root, right, and okay. Now, how to solve this problem? Okay, Actually, our goal is to make a full binary tree. So here is the definitions of the node. Okay, here is a class node which have data and two child left and right. And if we give any value, then it will initialize by data. The node will be initialized, and left and right will be null. Now, so in this class, we have made a class variable. It's called pre-index. This variable is for traversing on the pre-array. Okay, now see this. We have the function construct binary tree in which we have given pre and pre mirror. We will calculate the length of the pre. If the length is 0, which means we doesn't have any node, so we can just simply return null value. Or if this doesn't happen, then we will return our helper function. We will call our helper function and return. Okay. So we have made a helper function called construct, which having 4 parameters. First the pre-array, pre-mirror array, then 0 and n minus 1. These are nothing but the range from left to right in the pre-mirror. Okay. So this is the construct. We have made it a return type of node. Then it has pre-mirror and range from L to R. Okay. Now understood these two base cases. Okay. This is the another base cases that you will learn when you will dry run this. Okay. So understood this first. What is this? If we got pre-index means we are traversing on this array, pre-array, and this is greater than the length of the pre or equal to that, then it means that we have covered all the nodes. So that's why we can just simply return null. Okay. Otherwise, we can check the range left to right. In the pre-mirror, we have set to range L and R. If we got L is greater than R, which means like there is no element between the range, so we can just simply return. Okay. From the L to R, we have no element to assign as a child. Okay. So we will just return null. So this is the base case for our recursions. Okay. Now, next we have made root, in which we have taken new node. Because node is a constructor, we will pass a value from the pre-array and take the pre-index value, which means if in the starting it will be 0, so we will access the element 0. So root will be what? 0. Okay. And this is the another conditions. If L equals to R or pre-index is greater than equals to pre.length, then we have to return the root. So this condition is something which we have to we will learn when we dry run this. Okay. So forget about this. First of all, now see this one. Now we have made a variable next. Since pre-index is already incremented, then we can check the next left subtree. Okay. Let's suppose we have chosen 0. Now the next left subtree would be the next one. Okay. So we can start from the 1. So we have assigned to the next. Now we have the value of next. Now we want what is the position of the next in the pre-mirror. So that's why we will search for that. First of all, we make a variable index, which will starting from the range. Initially it is 0. We will start it from the L and search to the range from left to right where this element, this next element is exist. Okay. And we will get the index of this one. And after this, when we got the index, then we can call to the left and the right subtree call. Okay, in the left call, root dot left would be the construct pre mirror index to R. Okay, so understood this. First of all, next is what? Pre index. Okay, here we have next is what? 1. Now we find this index of 1 in the pre mirror, which is what? 2. Now you will see this pre mirror is divided into two main parts. First one this, and the second one is this. This two main part is nothing but this is the left subtree and the left part is the right subtree. Okay, here you can see as well. This part is in the left and this part is in the consider as in the right. Okay, so this is the left and this is the right. So while searching this index, we will able to separate our pre-mirror in two parts, the left subtree and the right subtree. Okay, then we will have the range from L is 1 and R is also donating to the 1. Then this condition will be true, which means we can just return the 1, which means we are on the last position. So we can just return. Okay, now after completing the left call, we have to move on the right call. Okay, in the right call, what we have? L plus 1 and index minus 1. So our index is what? 2, which is donating over there. So index minus 1, which will you donate on? I mean, which will be denote to 2. Okay, so 2 and L plus 1 is what? L is over there. L plus 1 will be here. So then again L equals to R. Again this condition will be true and then we can return. Okay, so this is the complete logic of the problem. If I dry run on this as well, you will get better idea of how the algorithm is working on this. Okay, so let's have a look. We have made a variable pre-index which will iterate on this pre-array, and for the pre-mirror we have range left and right. Idea is simple. What we are doing, we take an element root and take the next. We will find the next one in the pre-mirror. If we got the in the pre-mirror, and then the index will divide it this pre-mirror into two parts, left subtree and the right subtree, and then again we can go to the left and right. In this way we are able to solve the problem. Try to dry run this by your own self. You will get better idea how the recursion is working. Okay, so because tree is completely dependent on recursion, so you have to be very clear about recursion. So I think you get the idea how to solve the problem. So this is for today. Thank you. Thanks for watching the video. If you have any doubt, please leave your doubt in the comment section. If you have any kind of suggestions, you can leave this in comment as well. And if you are new into our channel, then please make sure you subscribe our channel and like the video. Thank you. Thanks for watching. And let's submit this as okay. This successfully submitted. Thank you. Thanks for watching.